Since the dawn of civilization, humans have sought ways to overcome geographical obstacles and connect with one another. Rivers, canyons, and other natural barriers have always posed significant challenges to travel and commerce. It was out of this necessity that the art and science of bridge building emerged. Bridges are far more than just structures of concrete and steel. They are powerful symbols of human ingenuity, connecting communities, cultures, and economies. From the earliest rudimentary crossings to the awe-inspiring spans of today, bridges have evolved dramatically over the centuries. Each era has brought new materials, techniques, and innovations, constantly pushing the boundaries of what is possible. This essay delves into the fascinating world of bridge construction, exploring the historical evolution of bridge building techniques, the engineering challenges involved in creating these colossal structures, and the profound societal impact they have had throughout history. We will journey from the timber and stone structures of antiquity to the soaring arches of the Roman Empire, and from the innovative iron bridges of the Industrial Revolution to the iconic suspension bridges that grace our modern skylines. The earliest bridges were rudimentary structures, often nothing more than fallen logs or simple beam bridges, consisting of a horizontal beam supported by two or more piers. These primitive crossings were limited in their span and load-bearing capacity, but they represented a crucial step in the development of bridge-building technology. As civilizations advanced, so too did their bridge-building skills. The use of stone as a building material marked a significant leap forward. Stone arch bridges, pioneered by the Romans, allowed for much larger spans and greater durability. The arch, with its ability to distribute weight outwards along its curve, proved to be an incredibly strong and enduring structural form. Roman engineers perfected the semicircular arch bridge, exemplified by iconic structures like the Pont du Gard in France and the Alcantara Bridge in Spain. These bridges, still standing today, are testaments to the ingenuity and craftsmanship of Roman engineers. The legacy of Roman bridge building extended far beyond the fall of the empire, influencing bridge design and construction throughout Europe and the Middle East for centuries to come. The Industrial Revolution brought with it new materials and technologies that would revolutionize bridge building. Iron, with its superior strength-to-weight ratio compared to stone, emerged as a key material in the 18th century. Cast iron and later wrought iron allowed engineers to create bridges with longer spans and lighter structures. The Iron Bridge in Shropshire, England, completed in 1779, stands as a testament to this pivotal era in bridge design. This pioneering structure, with its arch spanning 100 feet, demonstrated the potential of iron as a building material for bridges. The development of steel in the mid-19th century further propelled bridge building into a new era. Steel, an alloy of iron and carbon, offered even greater strength and durability than iron, enabling engineers to design and construct bridges of unprecedented scale and complexity. The use of steel paved the way for the emergence of new bridge types, including suspension bridges and cantilever bridges, which would come to define the late 19th and 20th centuries. Section 4. The Brooklyn Bridge, an engineering marvel. The Brooklyn Bridge, completed in 1883, stands as a testament to the ingenuity and ambition of late 19th century engineers. Designed by John A. Roebling and his son Washington Roebling, this iconic suspension bridge connects the boroughs of Manhattan and Brooklyn in New York City. At the time of its construction, the Brooklyn Bridge was the longest suspension bridge in the world, with a main span of 1,595 feet. Its construction was a monumental undertaking, fraught with challenges and setbacks, including caisson disease, also known as the bends, which afflicted many of the workers involved in the bridge's construction. Despite these challenges, the Brooklyn Bridge was completed and has stood for over a century as a symbol of American engineering prowess. Its distinctive neo-Gothic towers and intricate web of cables have made it one of the most recognizable bridges in the world. The Brooklyn Bridge marked a turning point in bridge design and construction, ushering in an era of ambitious suspension bridges that would redefine cityscapes around the world. Section 5. Modern marvels, suspension and cable-stayed bridges. The 20th century witnessed a surge in the construction of suspension bridges and cable-stayed bridges, particularly in the decades following World War II. These bridge types, enabled by advances in steel production and construction techniques, allowed engineers to span increasingly wider distances. Suspension bridges like the Golden Gate Bridge in San Francisco and the Akashi Kaikyo Bridge in Japan are characterized by their massive towers from which cables are strung supporting the bridge deck. Cable-stayed bridges such as the Millau Viaduct in France and the Erasmus Bridge in Rotterdam feature cables that run directly from the bridge deck to one or more towers. These modern marvels of engineering have not only connected communities and facilitated trade, but have also become iconic landmarks and symbols of human achievement. The graceful curves of a suspension bridge or the elegant geometry of a cable-stayed bridge never fail to inspire awe and wonder. As we move further into the 21st century, bridge engineers continue to push the boundaries of what is possible, exploring new materials, designs, and construction methods to create even more ambitious and awe-inspiring structures.